Number 2, the area of a semicircle is given by A equals 0.5 pi r squared, where r is the radius in inches. The semicircle displayed on a computer screen is increasing in size, and its dimensions are measured over a period of t seconds. Part A, if the semicircle has an area of 6 pi square inches, and its radius is increasing at a rate of 0.2 inches per second, at what rate is the area changing? Let's write down what we know. It tells us that there is an area of 6 pi, so A equals 6 pi. It says the radius is increasing at a rate of 0.25 inches per second, so that would be dr dt equals 0.25. And then it asked me at what rate is the area changing. So how fast is the area changing? So dA dt equals question mark. I do notice that they gave me a formula, so I'm going to write that down, 0.5 pi r squared. If I want to find information about dr dt and dA dt, I need to take the derivative. So the derivative of A would be dA dt. And then if I take the derivative of the right side, I will get 1 pi r dr dt. And then I'll try to plug in what I know. I know that dr dt is equal to 0.25. I'm looking for dA dt. I notice that I don't have r, so I need to do a little side trip. Okay, I do know that the area is equal to 6 pi, so I'm going to rewrite this area formula. And I know that the area is equal to 6 pi, so I'm going to solve this for r. So I'm going to divide both sides by 0.5 pi. The pi's cancel out, so I'll get 12 equals r squared. Then I'll square root both sides. I'll get r equals the square root of 12. So that's what I can put in over here. And if I do that, 1 times pi times the square root of 12 times 0.25 would be 2.721 inches squared per second. And I do need to do inches squared because we are talking about area. Part B, if the area of the semicircle is increasing at a constant rate of 8 square inches per second, is the radius of the semicircle increasing more rapidly when the radius is 2 inches or when the radius is 3 inches? Justify your answer. Okay, this time it's telling me how fast the area is increasing. So on this one, I can actually put dA dt is equal to 8. And this one is now asking me for the radius of the circle, and is it increasing? So I'm really looking for dr dt. But I need to compare it between when the radius is 2 and when the radius is 3. So I'm just going to put, first of all, when the radius is 2, and second of all, when that radius is 3. So I'm going to go from that derivative formula once again. That was pi r dr dt. This time we know for sure that dA dt is equal to 8. And then we're going to do two different problems. First of all, when the radius is equal to 2. When the radius is equal to 2, I'll end up doing 8 over 2 pi to get my dr dt, which would be 4 over pi. And if you wrote that as a decimal, that would equal 1.273. And then the next time I'm going to let my radius equal 3. And if I did that, I'll end up getting 8 over 3 pi would equal dr dt. And when I calculated that, I'm going to end up getting 0.849. And so is the radius of the semicircle increasing more rapidly when the radius is 2 or 3? I definitely noticed when I plugged in 2, I got a bigger answer. So that would be when the radius is 2 inches would be my answer. So I'm just going to put when the radius is 2 inches. One thing I want to caution you on this problem, when you go to type this in your calculator, very, very important that you put down here, I'd have to put the 2 pi in parentheses, and down here I'd have to put the 3 pi in the parentheses, otherwise you will not get the right answer.